Welcome to the future of point cloud measures, a revolutionary and patented mathematical process where actual point clouds during tunnel excavation are transformed to actual map or forecasting map. Virtual forecasting point clouds builds a virtual environment of future excavations during tunneling project. Point cloud forecasting provides useful information where future excavations can be estimated and predicted. Tremendous cost benefits can be achieved each time where point cloud forecasting is applied. Enjoy the presentation seminar as described through real showcases. Excavations during tunneling construction are not possible to approach the absolute theoretical surface. The main reason is the unexpected ground soil situations that can be found during infrastructure. Each excavation is dependent on personal or engineer's experience. There is a limitation of accurate decisions that would help to approach the best excavation result. This example represents the point cloud surface of an actual excavation. In order to estimate the future surface behavior so as to prevent critical excavation issues, different opinions may come from different people. The main reason behind those discrepancies is that there is not a realistic excavation forecasting based from previous point cloud measures. In addition, overbreak or underbreak areas that may cause from a bad excavation prediction increases dramatically the cost of construction. Generally, the excavation behavior for each particular soil is an unsolved issue that concerns many tunnel engineers. For every 10 centimeters of overbreaks may increase the excavation cost to more than €1 million per kilometer. The domino effect that may come from bad excavation prediction follows the project until the end. 1. Decrease safety. 2. Decrease excavation quality and performance. 3. Increase time schedule of works. 4. Increasing project costs. On the next steps, you will have the opportunity to learn how the particular invention provides the solution and the revolutionary approach for the unsolved issues as mentioned. As it known, point cloud measures from laser scanners represents the actual excavation surface. However, there is still not the technology to take all the advantages of point clouds in order to provide useful information for contractors. The current invention provides an advanced mathematical process that transforms point cloud data into projection mapping data. Projection mapping data will create useful actual maps where the developed tunnel surface will be readable from a plane view. The general projected view of mapping regions contributes in the forecast and division of future situations that are critical for the quality, the safety, and the cost of manufacture. When the responsible engineer or supervisor has printed the drawing of mapping, determines immediately the problematic regions and without time-consuming topographic support becomes the work of re-establishment direct and in very less time. Now let's turn our 3D drawing into plane view. What we see now is the development of excavation. The difference between original and developed excavation is obviously a complete inspection view that can be easily inspected from the plane view. The next processing after excavation development is the calculation of the inspection view that provides mapping informations showing the difference between the actual and theoretical excavation. The combination of excavation development and mapping inspection provides the absolute inspection control which is important for the project. Tunnel excavation forecasting provides sophisticated mathematical algorithms and a self-teaching process that learns from previous measures. Namely, the point clouds of each excavation are grouped according to each soil type. What you see now is the creation of virtual point clouds that represents the excavation forecasting estimation of the different soil types that exists more front where the actual excavation is. In the particular example, you can see the forecasting calculation of 4 future excavations. In addition, the forecasting virtual point clouds are transformed into developed mapping. Thus engineers will have the opportunity to inspect excavation forecastings from the plane view. Forecasting surface deformations are easily readable from the plane view, offering thus to engineers a priceless tool in order to predict and prevent excavation risks. Engineers can select several forecasting parameters. In accordance to the selection, point cloud forecasting is changing. This invention removes the obstacles between different opinions by adapting common basis forecasting informations where decisions can be taken instantly and at the same time more reliable and precise. The combination of the virtual point cloud forecasting and the reliable informations that can be provided helps engineers that come from different specializations such as geotechnical engineering, survey engineering, to work efficiently together in a common base and common decisions. Welcome to the future and the revolution of point clouds forecasting. Unfortunately, excavations never reach the perfect theoretical cylindrical tunnel round. Thus, significant overbreaks or underbreaks are created. In the particular example, the edge of the green line represents the perfect excavation, and the edge of the blue line represents the actual situation. As soon as point cloud forecasting is done, then explosives coordination system will calculate the recommended explosive quantities per drilling hole so as to prevent future overbreaks. Thus, the first step is to forecast an excavation that belongs to a particular soil. The second step is to define the possible overbreaks that will exist. The third step is to define the recommended explosive quantities per drilling hole so as to prevent overbreaks before are done. The fourth step is to update the forecasted surface, and thus engineers will have the opportunity to inspect the surface deformation that will be realized from the explosives adjustments to the particular areas. The scope is to reach the green line, which is the best possible result for our excavation. Excavation will become smoother, avoiding at the same time additional costly fill of concrete that would be caused from overbreaks. Now we are going to see the effect of surface that will be realized to the fourth forecasted excavation. Explosives coordination system will update the fourth forecasted surface. Update will estimate of how excavation surface could seem from potential explosives reduction. Namely, the particular mathematical process updates forecasting point clouds via the changes of explosives.